What's going on, everybody? Welcome back to my YouTube channel. Now, this is a very nice Olympiad question we have here, which says 4 plus the square root of 15 all raised to the power of x plus 4 minus the square root of 15 all raised to the power of x equal to 62. Well, in order to make this question easy for us to solve, we should agree on one fundamental principle. What is that principle? Let me show you here. Let's record that principle, which says that if I have x plus y, and I also have x minus y, both of them multiplying, this is equal to difference of 2 squared, which is x squared minus y squared. So I want to express this in terms of this because this one is having a positive sign and this one is having a negative sign, although both of them have the same number inside the bracket. So I'm trying to say that 4 plus the square root of 15 times 4 minus the square root of 15 is going to give us difference of 2 squares of the numbers inside. That means this is going to give us 4 squared, isn't that? Minus the square root of 15 squared. So this is a difference of 2 squared expressed in this form. So that means 4 plus the square root of 15 times 4 minus the square root of 15 is going to be 4 squared gives what? 16 minus. Now notice that square can cancel out square root, right? Leaving behind what? 15. So we have 4 plus the square root of 15 times 4 minus the square root of 15 to be equal to 16 minus 15 gives what? 1. Very good. You can see how simple this is getting. So I'll try to make this one the subject of formula. That means I have 4 minus the square root of 15 to be equal to 1 all over this I have here, which is 4 plus the square root of 15. So what did I just do? I just made this one a subject by dividing both sides by this. Now, what does this show? Or what does this one show? It shows that whenever I see 4 minus square root of 15, I should be substituting this. So this is a very remarkable equation for us. So I'm going to be putting this expression on our original question. So let's do that real quick. So this is 4 plus the square root of 15. So let's write it there. 4 plus the square root of 15. And this is raised to power s plus. Now, like I said, instead of me to write this, I should be writing what? This. Because that is what we have 4 minus the square root of 15 to be. So this is going to be 1 all over. So I'm writing 4 plus the square root of 15. Remember, this is raised to power s, so we have to raise that to power x. Equal to what? 62. Very good. We are really doing well. So now, notice that what I have here is the same thing as what I have here. So I can easily say that let P be equal to 4 plus the square root of 15 raised to power what? X. That means wherever I see 4 plus the square root of 15 to power s, I'll be substituting P. So I have P here, so you're going to be putting P plus 1 all over P equal to what? 62. Very good. Now we need to remove this fraction here. How do we remove this fraction? Is by using the LCM to multiply everything. And since I only have P as the only denominator, P becomes our LCM. So let's use P to multiply through in order to remove the fraction. So P times P, I'm using P to multiply through, P times 1 over P equal to P times 62. Now watch. P times P gives what? P squared plus, now P here can cancel off this P, leaving behind 1. equal to p times 62 gives you 62p. Now we need to arrange this because since the highest power is 2, it means this is a quadratic equation. So let's arrange it in a better setting. So this is p squared. And when 62p crosses to the left, it becomes minus 62p. Now I already have plus 1 here. So let's write it down. Equal to, now nothing will be remaining on the right. So I'll be writing 0. Now this is a quadratic equation. And if you should look at this quadratic equation properly, you notice that it cannot be factorized. And since it cannot be factorized, what do I do about it? I'm going to be using the general formula to solve that. So let's do that real quick. So the general formula is, since I'm looking for p equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. Well, before we continue, there is something I need to say. If you have been watching this video up to this point and you haven't subscribed, please do so to subscribe. And if you have been enjoying the video and you have been gaining value, please do wait to hit the like button and make sure to subscribe. Turn on the notification bell so you don't miss my upcoming video. So now let's continue. So from here, our a is the coefficient of p squared is 1. Our b is what? Coefficient of p is negative 62. So let's write negative 62 there. Then our c is this constant here, which is plus 1. It's going to be 1. So let's substitute into the general formula. So I have p equal to negative b, negative, our b is negative 62. So let's put it there. Negative 62 plus or minus the square root. This is Ben, man. So let's do this very well. So square root of b squared, b is negative 62. We have to square that minus 4 times a times c. A is 1 and c is 1. That means 4 times a, 1. C is also 1. Let's extend this a little and divide that by 2 times a. A is what? 1. Very good. So p now becomes negative times negative, guess what? Positive. Plus or minus the square root of negative 62 squared gives you 3844 minus 4 times 1 times 1 gives you 4. Now divide that by 2 because this 2 times 1 gives you what? 2. Very good. So p now becomes 62 plus or minus the square root of 3844 minus 4 gives you 3840. Now divide that by 2. Very good. We are moving forward. We are moving forward. Now, watch what is going to happen here. P now is equal to 62 plus or minus, well, 3840 is an irrational number, which means we cannot find a perfect square root for this. Now, what is going to happen here? We have to break this 3840 into 2. So let's break it in 2. And how am I going to do that? Remember, the original question is 4 plus the square root of 15. What am I saying? I'm saying that the original question has a square root of 15. So we need 15 inside the square root. So that means 15 times what? To give me 3840. So what am I multiplying 15 by to give me 3840? Well, that is going to be 256. Very good. Now divide by 2 we have there. Let me remove this so that it doesn't cause confusion. So now P is going to be equal to 62 plus or minus. Now 15 is an irrational number, which means I cannot have this perfect square root of 15. But 256 is a rational number. So the square root of 256 gives me what? 16. So Let's put the 16 outside, but this one remains in a square root. Are you seeing that? So divide by 2. Very good. Very good. We are really doing well in this case. So let's continue. So now P will be equal to 62 divided by 2 gives what? 31 plus or minus 16 divided by 2 is 8 root 15. Very good. Very good. So our P now is equal to 31. Let's take the plus first. Plus 8 root 15. Or P is 31. This time take the negative. Negative 8 root what? 15. Very good. So we have two cases here. So I'm going to be solving this in two cases. Here I'll say case 1. For the first case, remember what we said. We said P is equal to 4 plus the square root of 15 all raised to power x from our initial condition where we introduced P, right? Let me show you. This is it here. We said let P be equal to 4 plus the square root of 15 all raised to power x. And that is what we are going to be using until we have our final solution. So let's go. So for case 1, our P will be this value. So this first value we have is 31 plus 8 root 15, right? Cool. Equal to, now this is 4 plus the square root of 15 raised to power x. Now, there is something we need to do. Very, very important that we do this. And what is that? I need to split this 31 such that it has 15 in it. That means I'm looking for two numbers to add, and one of that number must be 15. So what can I add to 15 to give me 31? That should be 16, right? So let's put 16 there. 16 plus 15 gives me 31 plus 8 root 15 equal to what I have on the right, which is 4 plus the square root of 15 all raised to the power of x. Now, 16 is a perfect square. That means I can write 4 and square it. I can square 4 to give me 15, to give me 16. That is it. So 16 is a perfect square. That means 4 square gives me 16. Plus, now look at this 15. I want it to look exactly like square root of 15. So I'm going to be putting it in a square root of 15, which is this 15 here. But I cannot just put it in a square root without having to square it. So in order to validate you putting this 15 in a square root, you need to square the expression. So that is it. Plus, this is 8. I need to split this 8. That means I need to find two numbers to multiply to give me 8. And one of such number must be 4. Are you seeing that? Very good. So that means 2 times 4 gives me 8. So let's write it here. 2 times 4 gives me 8 here. Now write root 15. That's it. Equal to what I have on the right, which is what? 4 plus the square root of 15 all raised to power s. Very good. Very good. Now look at something. I want to say something here, and I'm going to be recording it. This is a fundamental rule. A truth be told. Fundamental rule. That means something that is always true. If I have a squared plus b squared plus 2ab, this is same as saying a plus b all squared. Is that not so? That is it. That is it. So now, look at our expression. Does it look anything like this? 4 squared plus the square root of 15 squared plus 2 times 4 square root of 15. Does it look like this? A squared plus b squared plus 2ab. Let's say these are a plus square root of 15 is our b plus 2. Remember, 4 is our a. That means 2a. Square root of 15 is b. It's the same thing, right? That means I can write 4 plus, just as it is here, 4 plus b. B is square root of 15. And do what? Square. Just as it is here. Since what I have here looks exactly as what I have here, that means I can express our expression here like this, which I just did. Equal to what I have on the right, which is 4 plus the square root of 15 all raised to power s. Now notice something very, very special here. You will notice that the base on the left is the same as the base on the right. And since the bases are equal, what happens? We equate the powers. So equate powers. So that means the power on the left is 2 is equal to the power on the right, which is what? X. Or we can write it in the proper way that S is equal to 2. That is it. We got this answer from what? Case 1. So let's consider case 2 and see which answer we're going to be getting. And what are we using to consider for case 2? Will be this our order value of P. So let's do that real quick. So for our case 2, our P is 31 minus 8 root 15. Now equal to 4 plus the square root of 15 raised to power s. You know, we still need to simplify this one just as we did in case 1. But in order for us not to waste time, there is something I need to show you. For case 1 of 31 plus 8 root 15, we got a simplification of 4 plus root 15 all raised to power 2. Because it has plus here, it resulted to plus here as well. So for our case 2, which has the same value as case 1, but the only difference is the sign here. This is positive and this is negative. We are still going to have the same result, but we'll be having negative here. So that is it. So let's save time by doing that. So that means I'll be having 4 minus, remember there is negative here, the square root of 15 to the power of 2. Very good, just as it is in case 1, but the only difference is positive here. So this is equal to what I have on the right, which is 4 plus the square root of 15 to the power of x. Now, notice the base. Are they the same? Now, they are not. So what do? Let's recall what we did since the beginning of the lecture. Let me show you real quick. Look at it here. We said 4 minus the square root of 15 is equal to 1 all over 4 plus the square root of 15. Is that not so? Very good. So let's express this one like that in the other side. Let's do that real quick. That means this is the same as writing 1 all over 4 plus the square root of what? 15. And since it is raised to power 2, we also have to raise this to power 2. That is it. Equal to what I have on the right, which is 4 plus the square root of 15 raised to power s. Now notice, this is an inverse. Is that not so? And an inverse represents a negative power. So I'll be writing the base, which is 4 plus the square root of 15. Notice that it has a positive power before, but since it is an inverse, it is going to be having a negative power of 2. Equal to what I have on the right hand side, which is 4 plus the square root of 15 raised to power s. Are you seeing that? Very good. Now look at the base. You will agree with me that the base are now equal. And since the base are equal, what do? We equate the powers. So let's equate powers. Let's equate powers. The power here on the left is negative 2. Equal to the power here on the right is what? X. That means negative 2 is equal to s, or let's write it in a proper way. S is equal to negative 2. Very good. So from everything we have done, we found out that s is equal to 2 from the first case And from the second case, we have s to be equal to -2. So these are the two values for s. You can go ahead and try that into the question given to us to see if we got the answer right. What do I mean? I mean, go ahead and put 2 for the value for s here in our original question to see if you're going to be getting 62. Also try that for -2. That is when s is -2. Try that here in the question to see if you're going to have 62. Very good. I believe that we have learned a lot from this lecture. And if you have really learned a lot and you really enjoyed this video, please do not hesitate to hit the like button, subscribe if you haven't, turn on the notification bell so you don't miss my upcoming video. And like I always say, until next time, take care.